Assalamualaikum warahmatullahi wabarakatuh. So we are from Group 1C. 1C. Today we are going to present the open-ended experiment for constructing programmable logic controller. So my name is Abdullah bin Abdul Wahab, and my group member is Muhammad Ishad, Jivan, and Ahmad Kushairi. So next. So for the objective of the experiment is first we need to construct PLC programs in LED using semantic software. The second objective is to conduct all operations involving the PLC switch, relay and delay. The third objective is to run and debug the programs in Panasonic FPS C30R. So next, for the introduction. So basically this experiment, a programmable logic control (PLC) or programmer controller is redesigned and modified industrial digital computer that we use to monitor production, assembly lines, robotic system or other operation. So PLC basically can vary in size from tiny modular device with a few tens of inputs and outputs in a housing built into the processor to massive rack mounted modular device with thousands of input output that are often networked with the other PLC and SCADA system. So this can be configured for a variety of digital and analog input output configuration as well as extended temperature range, electrical noise immunity, and vibration and impact resistance. So, program for controlling computer activity are normally played in non-volatile or battery-backed memory. So basically, PLC is first created in the automotive industry to substitute hardwired relay logic system with lightweight, durable, and easily programmable controllers. So there is extensive use as a as to control in rush condition system. So a PLC is example of hard real-time machine since output in fact must be achieved in a certain amount of time in response to input requirements or accidental activity. So next will be apparatus will be explained by yeah.
Yeah. Okay, thank you. Thank you, Abdullah. So I will present about the apparatus that we're using during the experiment. So first is the power supply. Second is connecting wire. Third is switch. Scroll down. And the last one is buzzer. So for the experimental procedure, so we will watch the video that we already recorded. Tiga. Okay, Assalamualaikum, Doctor. So we are from group 16 and we are going to show how to conduct experiment PLC. So first, for the experiment, we will use the software named Control FP1WIN Pro. And then first we have to set up the cinematic diagram like stated here. We will use two components, which is contact and then coil. And then after we finish set up the schematic diagram, we will click the online mode to make this diagram connected to the apparatus. So these are the apparatus that we're using to conduct the experiment. So the input will be connected to the switch, and then the output will be connected to the buzzer. And then if to see if the experiment is work, if we connect this wire into this power supply, this buzzer will produce a sound like this. So that's way the experiment is successfully conducted. Thank you.
Okay, thank you, Ishak. So I will explain about the second activity. So for the second activity, we will use two switch and also negation mode and also tone. Tone you can search it here and you just drag it and you can draw its schematic again. And after you connect on the wire, then the buzzer will produce sound. Then that's all for the second activity.
Okay, so that's all for the procedure and also the result. So let's proceed with the discussion.
Okay, for the discussion, basically the upper paragraph is all about the PLC programming, which is how it works and what kind of programming language that the PLC is used. And for our first activity, the ladder diagram is shown as in figure 5.2, which is consist of contact and coil labeled X0, R1, and Y6, and the circuit was connected between the switch buzzer and relay as shown in figure 9.1. After completing it, we made it online and download the program. The buzzer will turn on when the switch is pressed. Um, for the second activity, we are adding another one switch to our circuit. One switch will turn on the buzzer, another one will turn it off. Uh, the ladder diagram for this activity differs with the one uh, we done before because we have added three different icons, which is named X2, R1, TUN, which is the timer, and Y6, the coil, is changed to R1, and XO is changed to X1. And the ladder diagram for activity 2 is shown in figure 9.2. For the third activity, the ladder diagram is the same as the second activity, but we added the R1 contact, uh, Y6 coil, and internal special relay. The ladder diagram, as you can see in figure 7, we chose the relay number R901D relay, which is we want to delay the buzzer into 2 seconds, every 2 seconds, want to play it every 2 seconds. When the button is pushed, the buzzer will on and they will have delay 2 seconds before it's continue ringing. For the conclusion part, PLC program is in LAT using semantic software was successfully constructed, and all the operation involving PLC, switch, relay, and delay were able to conduct, and the program in Panasonic FPX C30R was successfully run the program. Okay, for the appendix part, uh, moving on to appendix. This is the figure 9.1. This is the arrangement for wire arrangement for the activity 1. And below is the figure 9.2 and the wire arrangements for the activity 2. And the last one, scroll down. Ah, okay, this is figure 9.3 and this is the wire arrangement for the activity 3. That's all from me. Thank you.
I think that's all for our upper-ended video for Lab 4. Thank you.